Alright, so week 14. This week was pushed back a bit because I was studying for exams and it was exhausting and tired, but I started this week ready and happy to get back into game development. I rested up from exams after being completely overworked from studying every time, and I was ready to get right back into it, and as soon as I opened up the game engine to start, it crashed. Whoa, it's fine. It's fine. Why is everything's fine? And this wasn't just any crash. Oh no, this was a bad crash, right? Like this was an airplane that fell onto the ground and caught fire, and the shark inside the airplane exploded, and sushi was everywhere. Except it wasn't sushi because the shark was on fire too. It was that kind of crash. It was bad. So basically, I was started really confused because I didn't make any changes during the past exam week, and it was crashing out. And I know I didn't make any changes because I was staying up absurd hours studying for classes, only to get a 70% in the exam and have it curved up to an A, which is fine. Anyway, so yeah, the game engine crashed. And this crash was really interesting because when it crashed, it was giving me a libc.so.6 error, which, for those of you who don't know, a low-level binary, instead of having all the instructions in one place, right? Because a computer program is such a collection of instructions, kind of like a recipe, right? Instead of having this massively long recipe that tells you the meaning of existence and everything, the programmers are smart. And we're like, okay, we're going to break that up into smaller chunks. So basically, a program will be a recipe, but metaphorically speaking, instead of telling you how to make a cake, it will tell you how to make a cake and then say, hey, to make icing, look at this other recipe over here. And that's what an SO file is. It's a separate program that the other program uses references to, so it doesn't have to be quite as large, right? And they're super useful. They're useful for a ton of different reasons, and honestly, it's a fantastic thing Godot uses them. But in this one case, this SO file was crashing. So I was like, okay, what do I do about this? And I know that in the past, I had issues with LMMS, or is it LLM? I always forget. Basically, the Linux sound software that I use. I had issues with an SO that was running, so I had to link a old SO link to a new SO, or was it the other way around? It may have been a new to old, I forget. But I forgot where the link was because I have a smooth brain and didn't save it. So I figured, okay, maybe this is the file that I linked to, and Godot thinks it's this old version, but it's actually a new version. So I need to get rid of this file in order for it to go to where it's supposed to go. So I deleted the file without saving it because I am smooth-brained. Well, as it turns out, that file is very important. So libc.6.so, I am now aware of, is used in pretty much everything. I'm not quite sure of this. I didn't do too much research on this particular task, but I'm pretty sure that that's the binary file that's used to compile, like, C together, which means it's just used everywhere. Like, this thing tells the computer how to read human, right? Like, it's used to convert C to binary, and then C references that, so when that thing's gone, the computer, doesn't know how to do a lot of really basic stuff. So as soon as I deleted that file, everything went to crap. It was so bad. If it was the plane crash with the fish was bad, this was a plane crash with the fish, but it was a blowfish. There were darts everywhere. It was bad, right? So Bash stopped working. I started getting an error. When I started getting an error, when I did LS, I started interestingly, the system ran okay, but that's because it was loaded already, right? As soon as I turned off my computer and turned it back on, the operating system crashed spectacularly. The kernel panicked and everything died, and it was crap. Oh, because I mentioned last week was exams week? Okay, so yeah, this happened. After the initial sort of panic, oh crap, I'm dead from exams, and now my computer's dead too. After that initial panic, right? I was like, okay, take a second, calm down, figure out what you need to do to fix it. And I realized, okay, I installed Arch Linux from this bootable USB drive. So again, computer science basics, for those of you who don't know, your computer needs an operating system to run, right? And that operating system relies on files like that SO file I deleted. And to get the operating system on the computer in the first place, you have to have it written down somewhere typically. So quote unquote written down. So you put it in either like a USB drive or an external drive and plug it in. That's how you install things like Arch Linux. You plug them. I install Arch Linux through a USB drive. So you get a bootable USB drive, you put the operating system on that, and you install it, which honestly, it's not as hard or fancy or technical as a lot of people make it out to be. The real technical stuff is building the operating system. Those people are wizards. But anyways, I digress. So yeah, you get it on the USB drive and put it in the thing. So I figured, okay, the USB drive has to run. Maybe it has that file, because that file's got to be online somewhere, right? So I downloaded Arch Linux on the USB drive, I plugged it in, and they added cowsay. So Arch Linux USB drive, forget the rest of this video. That is the most important information you'll get from this video. Cowsay is now the Arch Linux USB drive, and whoever added it is my new hero. But basically, I got the USB drive and plugged it into the computer. And when I did, after fiddling around with Find for a little bit, and admittedly a small panic where I couldn't find the file, I managed to find the file I was looking for, and with the computer running from the USB drive, moved that file onto the main disk where the operating system lives, and then it booted up and it worked happily. And it was a small crisis averted because of my own stupidity, which is fine. did I mention last week was exam week? So yeah, the computer's running. Don't delete that file is really bad. I still can't program my game because the game engine's crashing. So what was going on? This is the point where I took a step back and was like, okay, it's time to really seriously start debugging this. Godot is open source software. I can see where it's going from. Heck, if I solve a solution, then my solution is going to help a ton of other people running Linux. Let's freaking do this, right? So I went in and I started poking around Godot to see what was going on. This took... At first, I was just I started doing it just on my phone while I was on the go. I was like, yeah, what the heck? Let's look at Godot source code and see what I can do. And slowly, over the course of a few days, I managed to sort of get a basic grasp. I would not say I'm super familiar with code base anymore. I'm not familiar with it. But I would say I'm more familiar when I started, which I'm proud of. It's progress. So, yeah, we're more familiar with Godot's code base. And after significant amounts of poking around, I think I figured out where the issue's coming from. And to understand, I got to explain a little bit about how sound works on Linux first, for those of you who are unfamiliar. So on Linux, sound is implemented in 2 programs. It only needs to be one, but there's an optional program that's supposed to make it easier. Whether or not it actually does is seriously debated, and honestly, I don't know, because I don't know the first sound system very well, so I just have it the other one because it's easier. I know, shameful. But basically, the first program is called ALSA, and it stands for, oh geez, what does it stand for? Advanced Linux Sound Architecture. There we go. I memorized it. So, and this system is the main sound system on Linux, right? It's what's telling your computer how to interface with the sound devices. It tells the computer how to synthesize this stuff. And there might be more to it or less to it than I'm telling you because, again, I'm not super familiar with it. But the gist of it is, and the basic, and what you need to know from a programmer's perspective, from a debugging perspective, is that this thing is controlling sound on the machine, right? This is the library the program uses in our but it's also really complicated, right? There's lots of things with ALSA that can go horribly wrong, so people were like, okay, what if we wrap this with another program called Pulse Audio? And there's a few programs that do take this wrapping ALSA approach. Pulse Audio is only one of them, but that's the one that I happen to have on my computer. So in Godot, it turns out that sound... So first of all, obviously Godot runs on multiple different operating systems, which, by the way, is fantastic work from the people who programmed it. And the way this is done in Godot, there is a general driver class that the main program Godot uses. And then that driver class is changed depending on the operating system it's compiled. And this is very, very oversimplified, but it's changed depending on the operating system the computer is compiled on to contain different implementations of that driver class. So it's kind of like if you drive a car, right? You as the user don't know the individual mechanisms of the pedals making the car. Basically, when you press a pedal in a Jeep and a truck, you don't think, oh, this Jeep has to go to this circuit sends this signal here, and this circuit trickles that signal, but on a truck, it's different, and this circuit trickles this signal. You just think, oh, push the pedal down. That's what Godot does. It has this system for sound that says, oh, play the noise. Then, on different systems, that interpretation is compiled differently in different drivers. Well, those drivers are what sits in between the Godot and the hardware. That way Godot can run its logic without having to worry about the actual implementation of it. And those drivers need to be initialized. Before they can be run, they have to be wrapped so the Godot library knows what it is. It's kind of, because the drivers rely a lot on shared libraries, you kind of have to tell Godot where they're located at. It's a lot like, again, the analogy of the cake, right? The shared library is like the cake recipe that tells you to reference how to make icing over here. You have to tell it where that reference is. That's a step that's involved, right? So this is a step that happens inside Godot. And again, I'm significantly oversimplifying. But basically inside the Godot engine, before you can use the sound part of the engine, it initializes a specific driver, and the game engine will choose based on a list of drivers. And I think they pick I'm not sure where the driver number's coming from yet. I've been poking around the code for a while and I haven't found it. But they pick the first one first, and if that fails, they move on to the second one, and so on and so forth until they find a working sound driver, right? Well, it turns out that when you have Pulse Audio and ALSA, which again is optional, the MIDI system in Godot uses ALSA, but the sound system will use Pulse Audio. So Godot initializes the sound system, so it initializes Pulse Audio, and then when it tries to use ALSA, it goes, what is this? I don't know where the recipe for icing is. Crash horribly and explode. So that's basically what was going on. So I actually got a fix working for it. All you have to do is call the initialize ALSA function inside of the MIDI portion of Godot and Runs. And this fix quote unquote, is not really a fix, right? Because yes, it will get it to run, but to properly fix the software, you need to find a good place to put that initialize ALSA function that makes sense to the logic that's going on and then works properly. And I'm leaning right now to putting it inside the pulse audio initialize, because if you're on a system where pulse audio is initialized and you know ALSA is there and you know if they're going to use MIDI, you have to initialize ALSA, so why not just initialize it inside the pulse section? But I'm not super familiar with the Godot codebase, and I don't necessarily know if that's the best place for it yet, so if any of the 4 people watching this have an idea of where it is, that would be fantastic to tell me. If not, I think I'm going to spend a little bit more time looking at it, seeing if I can figure out more of where this issue's happening, and then see if there's a better location for it. If not, I'm just gonna put a pull request out, put that thing inside the pulse audio initialize, and let people on the internet tear it apart and find better ways to solve it. Because at least they'll get the bug fixed and get sort of the issue out there into the public. So yeah. I haven't done that yet because I actually don't know how to do a pull request and start contributing to open source software. So I kind of counted my chicken eggs before the hash in this case. But it's fine. It's working now, and I can program my game. My fix works, and it only works in my system, but that's fine. It's my system, and it works. So yeah, with that, I got to program into the game. So, do you remember this game design this video? This was a game design video, right? Yeah, this is about video games. Video games are a thing that exists. So basically, back on to game design. So, the main thing to work on in the game right now is the boss for the statue zone, because every zone is going to have 3 locations, with the third one being the boss, maybe more, maybe less, but it's at this point where I'm thinking, okay, I have the general motif for the statue zone finished, and the next thing to do is work on the boss for that zone, and I thought a lot about what I wanted this boss to be like, and eventually, because I was not convinced about the Spider-Head Medusa for a while, and then I drew it for the last video, and I was like, oh, you know what? I kind of like how that drawing turned out. Maybe it's not such a bad concept after all. And then I was like, okay, maybe the Spider-Head Medusa can have kind of like a centaur, but a spider, or not actually, because spiders are not a spider, a centipede. Yeah, centipede. It's got the main character, and then this sort of centipede tail coming after is the idea of the design. Or maybe I might actually just drop it in terms of the centipede, because I like centipedes cool. But I started thinking a lot about how I wanted to animate this centipede moving, right? Because if you think about a centipede, and bear with me for a moment, think about the spindly scary thing. If you think about the centipede with all of its legs, when it moves, it sort of turns and curves as it changes direction. It almost snakes along. It's a very funny word for it. It moves like a snake because it's a terrifying centipede, and all things that are noodles are terrifying. But basically, that's kind of the animation I want to implement. And I could do that by hand, right? I could make a few transition frames and then say, when you move this way, play this transition frame. When you move this way, play that other transition frame. But the logic for that would be really convoluted. It would be super noodly. Not to say that all noodles are terrifying, but the code would be terrifying too. You see, all noodles are terrifying. But that's the issue with code. It doesn't work, right? So I started thinking, how could I implement this better? And the first thing that I thought was, okay, those curves kind of look like parabolas. What if I just make a parabola through a circle and then draw a point from the center to the edge and then use that to sort of animate the direction it's going? And I actually came up with the math to draw a parabola from the center to an angle on a circle. The issue with that method is that when you draw a parabola that way, right, the method that I was using, at the top vertex of the parabola, the tangent line is always 0. So that's a really obnoxiously mathy technical way to say parabolas be flat at the point where they're curvy, right? And when a snake's line curves, it's not necessarily always facing upwards at that point. That tangent line would have to be at an angle to the curve. That you can't have that straight up, because it has to be in line with the direction that the snake is moving to curve. And you could solve this, right? You could use some fancy linear algebra to make the parabola curved on matrices and then curve it at an angle. But at that point I was like, well, even then that might work. It might be a valid solution, but I might find another valid solution easier if I go explore other techniques. So I figured, okay, what if I explore a different technique to solve this? And that got me thinking about the circle that I was using for the parabola. I almost was like, what if I have concentric rings of that circle and then move points along that ring to be segments of the body? So that's eventually what I ended up going with for the time being. And again, I still haven't completely solved the animation issue, but that's the technique that I'm using. And if you look at a circle, obviously, with the perspective of a game that I'm using, a straight circle does not fit for a centipede thing, right? When the centipede body would move behind the centipede, it would float above it, because it's just a circle on the screen, which is bad, right? That's not the perspective we're using. So if you actually look at circles, if you squish the equation for a circle, you squish it in the y-axis, it looks an awful lot like that circle is rotating in the z dimension. If you squint your eyes, actually, you're not even if you squint your eyes at it, because lo and behold, surprise, that's actually kind of what it's doing, right? If you take the equation for a circle and then throw cosine of another angle onto, multiply that by the y coordinate of a circle, you're actually rotating that circle inside 3 dimensions and then drawing it onto the 2-dimensional plane. It's a very, very basic form of the perspective math that's used in all sorts of different games. Super, super basic implementation of it. In fact, it's also very edge case and way more specific than any math those games would use. But it's basically the idea that you can draw this 3-dimensional shape onto a 2-dimensional screen. And I basically went with this and ran with it, right? I made an equation for how you rotate, obviously the equation for how you rotate the circle I just told you, and then I whipped up another equation for how a sphere drawn at any point along that circle would be scaled up or down. And I would not like to explain the proof for it because I'm bad at explaining complicated things and turn into a rambling idiot. But it probably works. It works enough that it looks like it works, so it's good for game design. And basically what I'm thinking is I'll take a lot of these concentric rings and then stack them together and then rotate them into the z dimension so they orbit around the main enemy and have a tail. And how the tail's going to work, all points will move at a constant speed, and they'll follow the first point, so they'll try to be as close to it as they can, and that first point will be in the opposite direction of velocity of the main objective. So if you can imagine the enemy moving straight while the tail is like facing straight down, the tail should theoretically curve the main point to be opposite the movement that's straight, and the other points would slowly curve around at their own speed because they have to travel farther to get there, and you'd have a nice curving motion as it moves forward. And that's hopefully what'll happen. The way I implemented that right now, when I went in and tested, is to just have the angle change of those points at a constant speed. But the issue with having the angle change is that changing the angle is not going to move them at a constant speed because larger circles move faster when you change the angle a certain amount, which is no bueno. It just makes it a long, boring straight line, and we don't like straight lines. Straight lines are boring. Be curvy. So, yeah, that's pretty much it for this week. It's not a lot of, like, actual... Oh, there is one actual game thing to show. I made a caterpillar. That's it. That's the actual game stuff that's implemented. There's not a lot of very, like, fanciful things this week. It's a lot of technical stuff because, again, I'm just coming off of finals week, and now I have a new job that I'm working, so I have less time to work on the game, but that's okay. I'm working on it when I can, and it's cool, and it's working, and we're getting good, and we're debugging it, and hopefully the debug fixes that I made will, I'll learn from it a ton, so I'll be able to use Godot's, like, low-level stuff a lot more than I would now. I'm actually considering making the math for the 3D circle inside a Godot C++ module instead of the usual GD script that I use, so that way it can, it'll run faster because it's using a lot of cosine and sine stuff. And then B, I forgot what the A and B was, so we're going to forget about B. So yeah, that's it for this week. See you next week.